Hey guys, so let me define the problem statement for this video. You have a large corpus of text. Think of it like hundreds or maybe thousands of pages of text. Okay, you are going to store that text into some kind of database, and then once it is stored in that database, you want to build a system on top of it so that if you give some query and query this database, you are able to retrieve the relevant documents from the whole corpus of text. Okay, so this is the fundamental problem statement. How we are going to solve it, we are going to discuss it further in this video. So let me explain you how we are going to solve this problem via a complete example and code walkthrough. Okay, so think of it like this is our whole corpus of text. So maybe actually in the start of the video I said that we will have thousands of lines or thousands of pages of text, and we are going to include store it in a database. But for the sake of explaining, okay, think of it like these 5 lines, okay, 5 paragraphs are our text corpus. Okay, so what we are going to do first, focus on this first line. Okay, this is line 1. We are going to tokenize this line. It means we are going to create individual words from this line. So global will become one token, warming will become another token, ease will become a third token. Okay, once we have these words, we are going to check what is the representation of word global in globe embeddings. Okay, so think of it like globe embeddings. Each word in globe embeddings have a corresponding vector, numerical vector with 100 elements in it. Okay, so global will have a vector, warming will have a vector. Okay, so for each line we will have multiple vectors, and each vector will be of 100 dimension. Okay, now once we have all those vectors, what we can do is we can take average of those vectors. So the first element of vector 1, then first element of vector 2, we take average of this and then create the first element of a resultant vector. Similarly, we take average of this and create the second element of the resultant vector. That way each line will contain a vector. Okay, and that vector will also be of 100 dimension if these individual vectors are of 100 dimensions, because what we are doing is we are taking element wise averaging. We are doing element wise averaging in here. Okay, so each line will be represented by a 100 element vector. So this line will be represented by 100 element vector. This line will also be represented by 100 element vector, like this. Okay, then we are going to store those 5 vectors, each of 100 elements, into a vector database. Okay, once we have stored those 5 vectors, or maybe n vectors based on the number of lines that you have in your corpus, you are going to do another thing. Once somebody want to query your database, so query will also be a text, then you will convert that query also into a 100 element vector. Okay, then you have a query vector and you have n number of vectors already stored into a database, and then you will kind of do some kind of similarity search. So you will do the pairwise similarity. So in pair, the one side will be the vector created using the query, and the other side will be individual vector embeddings already stored in your database, and whatever is the closest vector available in this database, that will become the result of this query. So that's how this text retrieval works. Okay, so in this code we are going to do the same thing. Okay, I will explain this code to you line by line. So in this code we need to import 3 things. We need to import the regular expression module, we need to import numpy, and we need to import scikit-learn. We will use scikit-learn to compute the cosine similarity between 2 vectors. So I have defined a function here, search similar text. Okay, this function has following arguments: query, query text, then lines represent the your corpus of text. Okay, so this corpus of text will be used to create the data store. Okay, then the text embeddings of this corpus of text, and then this is the globe file path. So basically this is the if you remember, I explained you globe model will have vector embeddings for all the words in its vocabulary. Okay, so this globe file path will have data something like this, word, and against that word the vector embeddings will be given. Okay, so I actually searched into ChatGPT what is globe embeddings. So it explained to me that globe embeddings comes in multiple flavors. We have used this globe embeddings with which is trained on a 6 billion tokens corpus. Okay, and each vector in this embedding is of 100 dimension. So that's how this name came, globe.6b.100d. Okay, so as explained here, for a given word we will have 100 dimension vector, for another word we will have 100 dimension vector, right? So let's move back to the code. So let's look at what this function is doing. Search similar text. Let's go to this function. Okay, so first of all, what it is doing, it is loading the globe embeddings. Okay, let's go to this function. Okay, so as I have explained you, let's keep it in side by side. Okay, so what this function is doing, it is first identifying the word and then identifying its corresponding embeddings. Okay, and then we are creating a Python dictionary where the key is the word and coefficient is these vector embeddings. Okay, now let's move back to the code. So we were where we were. Okay, we were here in this line. Okay, now let's move to the next line. So we need to convert the query to the embeddings also. Okay, so just like I explained here, so just like you need to convert your corpus and store it in a database store, once you need to do the similarity search, you also need to convert the query into the vector embeddings, that is in this kind of numerical form. Okay, so in this step we are doing that part. Then we need to compute the cosine similarity between query and text embeddings. Okay, so that's what we are going to do. We are going to do the pairwise cosine similarity search. Okay, so if you look at the import statement, here it is defined. It is actually a pairwise comparison. Okay, so you will get different similarity scores, and then out of those similarity scores, the one with the highest score will become the document result of your query. Okay, and we will return that document, we will return that text snippet. Okay, so that's all this whole code is doing. This code is self-explanatory. I'm going to put a link of this code in the video description, and that will be a public GitHub link. You just go to this code and try to understand this code. If you have any doubt, just leave a comment under my video and I will reply. Okay, so I think that's all for this video. I'm not going to walk through each and every line, okay, because if you know the Python, most of the lines are self-explanatory, but I have given you a fundamental idea, okay, how this problem can be solved. You first generate the word embeddings for your corpus, you generate the word embedding for your query, and then do a similarity search between whatever data is already stored in the database and your query, and you will get a relevant document. Cool. So just like this video and share with anybody who feel it will be useful for them, and just subscribe to my channel, because if you subscribe my channel I will be able to make more such video. Okay, so and leave the comment if you feel anything is not clear in this code. Just leave the video, leave the comment, and I will definitely going to answer it. Cool. See you in next video.